This conference will now be recorded.
All right.
All right, perfect. Anyway, you mentioned that in most cases you want your process centered, but there
Yeah,
are cases where you do not. But you didn't really explain. I just kind of wanted a little clarity there.
sure. Um, so for example, let's say I have pressure specs, okay, and this is the upper spec on pressure in a vacuum chamber, upper spec limit on pressure. So this is a vacuum chamber and
Okay,
lower.
you'll have to switch if you're doing something on the screen. You'll have to switch back to you.
Oh yeah, that's right. Can you see me now?
Yes, sir.
All right. So we have a vacuum chamber. We draw a vacuum, and this is the target value. The middle line there's the target value for where we want the pressure to be. And so we bring it down here, and we look at our quality report. And we notice that all the nonconformities for the last 10 years are above the upper spec limit. And there are 0 nonconformances on the lower spec limit. That's because when we draw a vacuum down here and we hold it for over time, this is the time axis, the x-axis, that we're going along here, and then there's a leak in the chamber and it comes up here and violates the upper spec limit. You with me?
Yes, sir.
Well, what you really want to do is you want to center risk is what you really want to do. So you may consider, hey, my risk must not be centered because over the last 10 years, I've had 100 nonconformances above the upper spec limit. So let's say 100 nonconformances above the upper spec limit and 0 nonconformances below the lower spec limit. Make sense?
Yes, sir.
And it's because I'm always getting leaks and that violates the upper spec limit. The only way I'm going to create a lower spec limit violation is if the pump sticks on, but it has never stuck on. And even if it does, you're going to get a non-conformance anyway, because by the time you go over and shut it off, it's going to be too late. Does that make sense?
Yes, sir.
So you may decide, hey, instead, what I'm going to do, instead of centering my value to center of specs, my process, I'm going to put it down here until I get equal numbers of non-conformances on the upper and lower side. Then my risk will be centered, but I may be much closer to my lower spec limit now. But there's some advantages of that, because if I have a leak before, I had this much time to react to it. Now, since I'm at this other scenario here, and it starts leaking, I have much more time to fix the problem.
Ah, okay. I see what
I'm saying?
Yes, sir.
Now with the CPK formulas, you'd say, oh no, you can't change it past the target value because that will really hurt our statistics. Who cares about the statistics? We're trying to minimize nonconformances. True?
Right.
Yeah. So in this case, yeah, our CP lower would be our CPK, and it would look terrible because you're just getting a little variation along this line here. So you can get it down here pretty close, and CP lower is going to look terrible. But it doesn't mean anything because the assumption of the CPK study is that distance from the spec limit to your target value, that equals risk, and it usually does. Usually your best risk is right between the two, but not always. In the case I just mentioned, you're better off lowering this thing way down here, and it's going to destroy your CPK. Why? because it says distance is equal to risk. And in some cases, it is not.
Okay. All right. All right. I think that clears it up.
Okay.
Okay.
But by far, it's more likely to be true that you want to center this. But you can always go center this, and over time, look to see you should have equal number of failures on the bottom and lower, on the upper side and the lower side.
Right. Yeah.
If distance equals risk. If distance equals risk, you'll put it right in between here, and you'll get equal failure on both sides.
Right. Okay. Okay.
And sometimes the violation of the lower spec limit isn't as damning as violating the upper spec limit. So that's where you also want to balance risk. And it may not be centered.
Okay. All right. And what I'll do is I can access my document. So as much as possible, if it, like on something like this where I can just read it off to you, we won't have to switch back and forth. But there's some stuff that you may have to actually see, but that'll minimize switching back and forth. Okay, the next one, let's see here. Yeah, this one you'll probably have to see, so you'll probably have to switch back to my screen.
Yeah, this is a
test question. This is a test question that I could not get the answer to.
Yeah.
All right, that one right there in the center. I answered it correct, but I was just guessing. So, and it didn't give a description as to how you calculate it. So,
all right. Using the 3 samples to calculate upper and lower control limit, how many sample means will fall outside? And that should be of, not or. Fall outside the upper. Oh no, it's or. How many sample means will fall outside the upper or lower control limits? Okay. First, we have to calculate the upper and lower control limits. Okay, so we have to calculate the average of each one of these, of each one of those. Let me see if I can't pull this over here. No, I can't. Okay.
Okay. So if I add up, add up all the numbers in each set, and then divide it by the number in the set, and get the average of each one.
But you should use your calculator function. It's going to make it a lot quicker, and you're on a time test. So let me remind you how to do that. You go 3.
If you want to switch back to you, if you're doing.
Oh shoot! Yeah.
Okay.
And you'll have to read off the numbers to me.
Okay, I can do that. Let me shrink this so I can see you and it at the same time.
Yeah.
All right, let's get this over here. And okay, the first data set is 3, 5, 9, 2, 10, 4, 8.
Some of those numbers were negative, weren't they?
No.
Okay.
Oh, I know the reason you thought that. I should probably change that because it's going to confuse you real quick. What I do is I don't even know what it's called, but it's that little backwards P looking thing that shows everything. Okay. And there's dots that made it look like they were.
Oh, okay. Anyway, did you see how I put those numbers in memory?
Yes,
Okay, then I go second function and hit the X bar button. X squared, right above X squared is X bar. So I go second function. And this is the way you should do it because it's quicker and you're less likely to make mistakes when you do it the simpler way. So the average for this one, this sample, we'll call it X bar 1, equals 5.857. That's good enough. Okay. And the range for sample set 1, what was the high and the low on that one? What was the high?
The high was 10
Okay.
and the low was 2.
Okay.
So you're calculating average and range on that each set?
Yes.
Oh, see, that's why I couldn't figure it out. Okay.
And then you do each one of those. Then you take the average of the averages, which will give you X double bar, correct?
Yes, sir.
And then you'll calculate the average of all the ranges, which will give you R bar.
Okay, so let me see here. So you get the average of the averages, the average of the range, add those two together.
No, not add them together yet.
Okay, I'm sorry.
But you see how to calculate X double bar and R bar, correct? Because you're going to be calculating this for every set of numbers you have. How many do you have? 3 of them?
Yeah, 3 sets.
Yeah. So you'll have X bar 1, X bar 2, X bar 3, and R1, R2, and R3.
Okay, and then you get the average of each of those?
Yeah, then you take the average of the averages to get your X double bar, and you take your average of your 3 ranges to get your R bar.
Okay, and then you divide X by R.
Well, no, I'm not dividing.
Oh.
That's R bar and X double bar. And then you have to get A2, so I don't confuse you on that. I'm going to put, you have to calculate X bar and you have to calculate R bar. Okay? Then you have to get A2. What sample size did we have?
That was 6 or 7.
6.
1, 2, 3, 4, 5, 6, 7.
N equals 7. Okay? And then you'll go to that table where you can look up your A2 constant for a sample size of 7. Are you okay with that?
Yeah.
Okay. So now you have 3 numbers that we've calculated. X double bar, which was the average of X bar 1, X bar 2, X bar 3. The average range, which was from all 3. A2 came from the table where we go and look up N equals 7 at the A2 column. Then you just simply do this, upper control limit equals X double bar plus A2 times R bar. So we already have these 3 numbers. We just plug them into this formula.
Okay.
That will give us the value of the upper control limit. Then the lower control limit, of course, will be X double bar minus A2 times R bar.
Okay.
Plug those numbers in. That will give us our upper and lower control limit. Then we plot these averages on this average chart, now that we know the upper and lower control limit. And you may have to do the same for the range chart. I can't remember. What did the question say? Did it say how many fall outside the average chart, the range chart, or both?
It says how many sample means will fall outside the upper or lower control limits.
Okay, so we don't have to worry about the range chart then. Sometimes they'll have you do the range chart also, but not on this one. So then we'll take each of these averages and we'll see if it falls between the upper and lower control limit. Then we'll go to number 2 average and see if it is within the control limits. Then we'll go to the 3rd sample average and see if it falls within the control limits. And that's how many we'll figure out how many fall outside the control limits.
Okay, I'll try to play with that and see if I can get that. I don't know how come I missed that if it was in the module, but yeah, that sounds pretty simple. Okay.
Okay.
All right. And then let's go to the next one here. Let's see. Okay, the next one has to do with the I don't know what to call it. The K. So let me read how it says. You don't explain where the K numbers come from. Oh, okay. Yeah, I'll show you. Um, in the
Oh, in the
GTR
measurement
module,
system
the measurement system
analysis.
analysis.
Yeah, you don't have to worry about that.
Okay.
I've never seen them test on that.
Okay.
K just comes from a table from AIAG, Automotive Industry Action Group. They came up with some constants in a table.
Okay. The reason I got confused is I had found a table that all the SPC terms, and it had K on there, and the K was K means the number of subgroups, but you had numbers with these Ks.
Yeah,
Now the
it's
K
a different K.
I was going to say that was a small case, a lowercase K, and the one that you have there is a capital K. So these are totally different.
Yes, they are.
Okay, so I'm not gonna have to worry about that because you had
you don't have to worry
this
about
formula
that.
right here, K2.
Yeah.
And I'm like, I don't know how to figure all that out. So
No, I wouldn't worry about that. But you do need to worry about all the vocabulary and what gauge R&R is, what repeatability, reproducibility is, the different names that they're known by. Remember, repeatability is also known as what? Precision and sigma of equipment.
Right. Yeah. I think I'm pretty good with the rest of the stuff. I was just confused with the K there.
Yeah.
Okay. Let's see. And then right here where this NR is, it looked like to me it should have been NR like I have it here, N times R instead of just all in together. Shouldn't it have been?
I'd have to look at that. I'm not sure.
Oh, okay.
But they're not going to test you on that.
Okay. All right. No problem.
Yeah.
All right. Okay. Now next here, regarding true value or accepted reference value, this is just an offhanded question. When is it adjusted? Is it like a technological advanced, or when you hit it, you adjust up from there, or?
I'm trying to think of was this in the gauge R&R study? Oh,
yes.
yeah. Okay, got it. Yeah, the true value is the actual value in reality. But to measurement people, the true value is a mystical figure, a mystical figure.
You call it the accepted reference value that you establish.
Yes.
That you're shooting for.
Yeah.
But at some point, you've got to, you got to change that at some point because technological advance, or you reach that accepted reference value. When does it ever change?
What changes?
Your accepted reference value. In other words, there's an accepted reference value that's established, but I'm sure at some point
accepted reference value is what you measured it to be.
Yeah, it's the way the definition was that the accepted reference value was you take the most technologically advanced, the number one appraiser operator, or the best equipment.
Machine the best equipment
you have to do something. That's your reference value. But then you have your normal everyday values that are going to come about. So you're shooting for that reference value. So at some point, though, that reference value's got to change to even a higher level. When would that happen?
Well, if you had got better equipment.
Okay.
More accurate equipment.
Okay, so like better equipment, you reestablish the reference value.
And you measure the same part, and because it's a better measuring system, it's going to be closer to the truth.
Okay.
Value.
All right. Let's see here. Okay, that's not that one. This one here. All right, let's see here. Certain range of it. Okay, in the equation below, that you can see here, hopefully, and it's if I needed to pull up the PDF, I could.
No,
this is the equation that was in the PDF, and it, and you have your answer at 0.0366.
Yeah.
and right here I have 0.19122 squared is 0.0366. The square root though of 0.036 is 1.919131. Shouldn't this be the answer? Because the next example you do it that way. So in other words, you squared it instead of square rooted it.
Oh, I see what you're saying. Yeah, but when you take the square root of a square, you're going to end up with 0.19122.
Let's see here.
I mean, you can do it with your calculator. Go 0.19122 squared gives you 0.365, correct? 0.0365.
Now let me change 0.0366 if you round up. Yeah.
Now now just take the square root of that.
The square root of that number?
Yeah.
Okay.
Gives you 0.19122.
Right.
So what was your question?
I thought, let's see, that's squared. Maybe this one I did a little while back, and I'm trying to remember exactly what I was the point I was trying to make is that, okay, so you squared that and that, and then you get the square root of that answer. Maybe that's what I was thinking. Maybe I accidentally, okay, you have to gauge on our answer as 3106. Okay. 0.1992 squared is 0.036. The square root of 3 is 3. Shouldn't this be the answer? Oh, okay. I think what it is that, okay, the answer you have is 0.0136. I thought the answer should be, because it's the square root, I thought the answer should be 1 or 0.19131 because
I'd have to see the PDF on that one because I'm not sure what's going on.
Okay, let's see what page it is, and I'll pull it up real quick.
Okay.
Page 57 of that one. Okay, let's see if I've got it already up. Non-normal probability, gauge R. Page 57. Okay, right here. Let's see. Yeah, that's it right there.
Yeah, you may be correct. That may be wrong. Yeah, that's messed up.
Aha, well, good. I was getting confused there.
Yeah, no, that should be 0.19122.
You mean, well, actually, I had it different. I had it as the square root. Okay, yeah, so you got it right. Okay, so you changed it. That is, I was correct in that. Let's see. No, let's see. Square root of 0.036. Okay. So you're saying the gauge R&R should be, I got it as, shoot, this thing is hard to navigate. Let's see, maybe if I do it this way. All right, maybe I can figure it out this way. Okay. See, I had it as 0.19131.
Yeah, what I did is I just took 0.19122 and squared it and gave that to be the answer. And I didn't take the square root.
Okay, so you take the squared, and that, as you said, is like your answer is 0.0366. Okay,
Yeah,
and
which
then
I
you
called
add,
the answer, but I didn't
and,
take the square root.
and then
Take
you
the
add,
square root.
yeah, and then you take the square root of that, exactly.
That's 0.19122.
Right, and that
And
should
that
be the
should have been the answer.
aha. Okay, good.
Yeah.
All right. Okay, good. All right, next question here. Let's close this thing out. It doesn't come. Is there any way to get rid of this darn thing? I guess it stays there permanent. I can't get rid of this for some reason. Dang. All right, hold on. I can do it down here. Let's see, it's the last one. Okay, good. All right. This one. All right.
Blow that up if you can.
Okay. All right. This is the next question here. Let's see here. Let's see what my question was. I cannot figure out where. Okay, in your answer, I'll show you the deal, but just to let you know, the right here we have 0.067 that you were using in your solution. I couldn't figure out how you came up with that, but let me see if you need it bigger. I can even get it bigger for you.
No,
Well,
I
it's not
can
letting
see
me
it.
do it that way. Let's see if I can do this.
I can see it.
Oops.
Oh, okay.
Jeez. Okay, there we go.
There you go. All right. So you use the R squared method.
And this is
Or
your.
I'm sorry, you'll use the range method.
Okay, and
So pull it up where I can see that question.
okay. Dang it. When I do that, I can't center the thing or pull it over for you. Okay.
There you go. That's good. Okay, so
Okay, so switch back to you so I can see you doing your thing.
well, I have to see the numbers again.
Oh, okay. Save.
Okay, so part one, first operator was number one was 1.258, correct?
Yes.
Okay, and what was operator number two? What did they get for that one?
1.245.
And operator two got 1.253.
Operator one performs 3 measurements. Oh, okay. Wait a
Operator
minute.
one measured part one, and operator two measured part one. Operator one measured 1.258. Operator two measured 1.252.
No.
Or 1.253.
Yes, on part one. Yes.
Yeah. Okay.
And then
And now let's look at the second part, operator. Let me get this written down right. Okay. So that was part number one. What about part number two? What did operator one measure part number two at?
operator one, part number two is 12.45.
1.245.
1.245, yes, sorry.
Yeah. And what did operator two measure part number two to be?
1.252.
1.252. Okay. And part number three, operator one.
Operator one, part number three, 1.228.
Okay. And what did operator two measure that at?
1.220.
Okay. Now I'm going to flip back and make me the presenter here.
Okay.
Okay, so here's my table. Operator one measured part number one to be this. Operator two measured to be that, correct?
I'm going to make sure by pulling my Word document up, making sure we get everything on the same page here. Okay. 2.5. Okay. 1.258, 2.53,
Equals
2.45,
5 thousandths.
2.2, and 1.2.8, 1.2. Okay, yeah, we got all the numbers right.
So now I'm calculating the range. Okay. Now this one, you always take the larger one, subtract the smaller one from it when you're doing the range.
Right.
This one is 8 thousandths. Okay, then I'm going to calculate R bar, which will be the average of all these ranges. So 0.005, put it in the memory, 0.0, oh, come on, 0.005, 0.007, 0.008, and average gives me 0.00666, whatever.
Okay, that's where I could not figure out how you got that. So let me see here, because I'm trying to see my screen and yours at the same time. It's difficult. So you added. Okay, how did you get the? I'm not getting where the point. Let's see, 1.258 plus 1.253 divided by.
No, you just subtract. We're doing the range. 1.258 minus 1.253. Remember, the range is the largest number minus the smaller number.
Right. Okay, I'm sorry. Okay, so,
Yeah.
And then, so 1.258 minus 1.253 equals. Okay, so that's, I don't know how I'm, it was a while back. I don't want to bug you too much. And
No, you're
sometimes
good.
some of this stuff is, I do it and I'm in the moment and I know I'm doing it. And then it's, weeks later, then I finally getting in touch with you and I'm having to, bring it back to my mind. And
That's
I don't
okay.
know.
That's a good exercise in and of itself.
Okay. So that's how you got the 06. That's what I couldn't figure out. I'm like,
Yeah.
however I did it, I wasn't doing it the way you've done it here, and I couldn't get that 0.0067.
Yeah.
Wait a minute now. Let's see. In your answer, you got 0.0067. There, you got 0.006. Oh, okay. So
Oh,
you just
yeah.
rounded off in the answer.
That
Okay.
should be, yeah, that should be 0.00.
Okay. All right. So you got that. Therefore, divided by. Okay. Now go ahead and you can go ahead and finish the calculation now. Now I know where you got the 0.067.
Yeah. Now it's R bar over D2. We know R bar is this. Divided by D2, which you look up in the table.
Right. Okay.
And it's the number of numbers I used. Well, what is the number?
D2, you've got here 1.23105.
All right, 1.2305, which I got out of the instructor notes. There's a table in there where you go over the number of operators and the number of parts.
That's 23105.
Oh. Is that correct?
No, no, it's 1.23105.
1.23105.
Yes, sir.
Okay. But
And then
that's where you
that-
get it out of that table. It was the number of parts and the number of operators. You have 2 operators.
Yeah, I was good there. Where I screwed up was where you were. I think what I did is I added up operator one's parts and got the average of that.
Okay.
And then the way you're doing it, you're taking each part and doing the average of that between
That's
the two
right.
operators. That's where I got screwed up.
Yeah, I'm doing that range. Yeah.
Yeah. Okay. That's where I got
And I
screwed up.
calculate the average of the ranges.
Right. Yeah. Okay. Yeah. I'm pretty sure that's what I did wrong is I added operator one, all of his calculations. So, and I see why that was stupid, but I don't know. I think that's what I did wrong anyway.
Yeah.
It's so
Okay.
long ago now. I've forgotten, but anyway, this recording will help me figure it out.
Yeah.
Because the main thing I couldn't get where you got the 0.0067.
Yeah.
Okay, next question here. Let's see here. All right, it is another test question, so you'll probably have to see that.
Okay.
And this is in the Z statistic capability module.
Okay.
And by the way, sometimes what I do is on these math questions,
Yeah.
even if I know the answer, I'll answer it wrong just so I can see your explanations.
Yeah.
And it's like right here, I knew what the answer was, but I did it incorrect. And if you'll see here, if you'll okay, share, look at the question and then look at how you solved it, and then look in the red on how I solved it.
Okay.
And I don't understand your math so much, so you can see why mine seems simpler.
Did you get the right answer?
Yeah, I got the right answer, but a completely different way. And that's why I wanted you to look at those two
Okay.
and say, well, which way? Because I don't, I'm worried about what's coming in the future. So if I did it this way, but I need to know how to do it your way because I'm going to need to do it in the future, I need to learn your way.
Yeah. Okay.
You understanding the two differences there?
Well, you did it simpler, that's for sure. But what you did is just fine.
Okay.
You look
Now where,
that up and
just so
you
I
look
know,
that
where did
one.
that, does that 0.5 come from the alpha risk?
Yeah, let me show you how I did it.
All right, switch back to you,
Yeah.
and then I'll shrink this.
Okay, so here we are. And first of all, the math is pretty easy because this is the average, 25, correct?
Yes, sir.
Sigma is equal to 1. So there's 27 here, which means there's 2 sigmas. And this is 24, which means it's 1 sigma. But if you don't understand that, we can do the math. So let's do Z upper first. Equals 27 minus 25 divided by the value of standard deviation, which is 1, which gives us 2. Okay, that's how I got the 2 sigma here.
Okay, what, I'm sorry, what is the something equals, what is that? I can't
This
quite.
is Z upper.
Oh, Z upper, okay. Okay. It's 27 minus
And
25,
it
20.
equals upper spec limit, which is 27, minus the average, which is 25, divided by the value of standard deviation, which equals 1. And so I do the math and I get 2. Z equals 2. Remember what Z is? Z is the number of sigmas from the average to a value of interest.
Right.
So when this is 2, it really means 2 sigma.
2 sigma, right.
So that's where I got that. Then I do Z lower equals the average minus the lower spec limit divided by sigma equals 25 minus 24 divided by 1 is 1. And that's where I got the 1 sigma.
Okay. So I'm trying to read your 27, 25, Z upper, 2, table, Z lower, 25, 1. Okay, our table. Okay, I get that part. Okay.
All right. So now I go to the Z table and I look up 2. It's 0.0228. So this area here.
What is that 0.5 though? That's what I couldn't get where you were getting the 0.5 minus.
I'll show you here in a little bit. I mean, I made it harder than I should have. You did it the easy way. Okay, then I'm going to look up 1 sigma, 1.00.1587. So this area here is 0.1587. You with me?
Yes, sir.
Okay. And I want to know this red area. The question's asking for that area, correct?
Right.
So you did the right thing. You added these together and subtracted from 1. And that's the right way of doing it. The way I did it is I said, okay, I want to calculate this area and add it to this area because I wasn't thinking very well. I mean, I still figured it out, but I made it more difficult than it needed to be. So this is 0.5 of the area goes from here to here, correct?
Yeah. Oh, okay.
So
Yeah.
I took this 0.0228 and I subtracted it from 0.5. That gave me this area right here to the right of the average.
I see.
And then I went to the other one and went 0.1587 and I subtracted that from 0.5, gave me this area.
Right.
Then I added those two areas together, but the way you did it was much easier.
Okay.
Yeah.
All right. Well, I mean, it's good to know both ways because, you know,
Yeah,
again, I don't
that's
know
right.
what's coming in the future.
Yeah, that's true.
Okay. All right. All right. Good. Good. All right. Now let me see if I can do the next one without having you to have to switch. Oh, shoot. Actually, you might be able to do this one easy. Let's see here. Let me read what I said. Okay. Yeah, it's probably best for you to see it.
Yeah.
I hate when it goes between two pages, and all right. Actually, I can just say what I want to say here. Okay, and this one here, it's the coin flip, and you got the probability of flipping on tails and the probability of rolling an odd number on the dice. And then if you look at your answer there, I get how to do all that stuff. My question though is, I don't understand why the answer is 3 divided by 12 versus the answer not just being 25. I don't know how you get 3 divided by 12.
Okay. Let me see. Oh, because there's 12 possibilities? No.
I figured out every way that I figured like 2 or 3 different ways to do this, and every one of them came out with 25%. I couldn't get to 3 divided by 12.
This is an AND statement problem. We are looking for getting an odd number on the die. And there are 3 odd numbers, right?
Yes.
These are independent events, so it is just a matter of multiplying the 2 probabilities. The probability of getting a tails is 1/2. We got that.
Right.
Odds of getting an odd number from the roll of the die is 3 out of 6. That's
Which
correct.
is also 0.5.
Yeah.
Multiply those together, you get 25%. That was the first way I did it.
Yeah. Well, it's the same thing because 3/6 is the same as 1/2.
Right. Yeah, exactly. That's what I'm saying is that on a test though, I would have had absolutely no idea how you got 312. I'm just
Or 3
figuring
over 6, you mean? Yeah. But you knew it was 0.5, so you were all right. But it's 3 out of 6 because there's 3 odd when you throw a die, there's 3 odd numbers and 6 numbers total.
Yeah, but what I'm saying is your answer is 3 over 12, and everything that I did, my answer was 20.25 or 25%. I would, in this test, I really did get it wrong because I didn't do it on purpose and get it wrong. I don't know how I would answer that 3 over 12, and unless I guess, so in this example, I'm supposed to figure out what the percentage is of every answer to get because 25% is the answer. That's weird.
Yeah, 25% is the answer because you multiply 0.5 times 0.5 and you get 0.25.
Exactly, but the answer of the question is not 25%. It's 3 over 12.
I know, but that is 25%. If you get your calculator and go 3 over 12, it's 25%.
Yeah, I know that. That's what I'm saying though, is that in a test, they would do it this way to where they're trying to trick you to where
they might. Yeah, but let me show you how to do it. So I'm going to do that. I'm going to write this down. 1/2.
Got to switch back to you.
Times 3 divided by 6. Yeah. Okay.
Okay.
So I'm just going to show you how to use your calculator on these.
Okay.
So I'm going to use my calculator to go 1/2 times 3/6. And you could do it otherwise. 3 times 1 is 3, 2 times 6 is 12, 3/12. But anyway, let me show you how to do it on the calculator. 1/2, the way you do it on the calculator is go 1, then hit this ABC button, and 2. In the calculator, this means 1/2. So
You mean
1/2,
RCO? Oh, ABC. I see it. Okay.
yeah. Then I go times 3/6, 3 ABC 6 equals 1/4.
Okay, but now you got 1/4 again, which is still 25%. So it's still the answer. It still is at 3/12. That's what I'm saying is
Yeah.
that I
But
would have
if
had
you
to.
do this manually, you go 3 times 1, multiply the numerators is 3, multiply the denominators is 12.
Oh, that's how they got it.
Yeah. And then if you want to convert that, you can always convert these back. Let me show you how to do that. So I'm going to enter 3/12 in my calculator. You with me?
Yes, sir.
Now, if I want to convert that into a decimal, all I have to do is go second function, arrow. It gives me 0.25.
Wow.
And
Okay.
if I want to take it back to fraction, I just go second function, arrow again. It's a toggle. It switches it back and forth.
Okay. It goes to 1/4 instead of 3/12 when you do that.
Yeah, that's right, because it'll round it to its lowest common denominator.
I see.
Will. But yeah, they'll
Wow.
do stuff like that once in a while. Not very
Okay.
often.
So
Not
that's
very
how.
often, but sometimes.
So they will test you this way to where it won't be 25%. You've got to figure out the 3/12.
Yeah, but you can just take 3/12 and go 3 divided by 12 does the same thing.
Yes, and that's how I was getting the answer there. That's what I'm saying is that had no problems, like 4 different ways of getting 25%. I couldn't get 3/12, which is the answer.
Yeah, but if you take 3 divided by 12, you'll find out it's 25%. 3 divided by 12 is
Yeah,
25. Oh, okay, 3/12 is 25%. Therefore, that's the correct answer.
right. Yeah. So that's what I'm saying is that I could not figure out how to do the 3/12, but now you show again all the 25s you showed me. I figured out all that myself. I just couldn't get the 3/12 as the answer, which is the answer to the test. And I'm like, would they really test you that way? But I guess they do.
They will sometimes. It's not
Okay.
often, but you'll probably get one on the test.
Okay. All right. Let's see the next one. Okay. Now this next one, yeah, you'll definitely have to see this next one.
Okay.
And I'll blow it up. Let's see here. Yeah, I can get it all on one page there. That's good. Okay, now this one is a little complicated. Or it's not complicated, but it's just you'll have to read it to really see everything that's going on. Essentially, what this is this is in the probability statistics module.
Yeah.
And in the PDF on page 43, let me pull that up real quick.
Okay.
Actually, you know what? It didn't matter. That's right. I pulled it up, but it doesn't make sense for what I did because what it is that you went through the step-by-step instructions on how to establish a standard to design a process around. But on the PDF, you didn't put that in there. So what I did here is I created out a written step-by-step that you did. And then on the PDF, you used one set of numbers, but in the video, you used a different set of numbers.
Yeah, that's right.
And then in the video, you were doing, you had all these, like 10,000s and this and that, and you stroked out all the zeros. I didn't know how to do all that stuff, so I stuck with the original numbers you used in the PDF to make it simpler.
Yeah.
So I followed every step that you got there. Yeah. And I was understanding it all the way. I thought I was doing good, but my answer didn't come out the way that your answer did.
Yeah.
And I got in red in number 6 here. I got in red where I think I might have gone wrong. But if you will, just read steps 1 through 8 and see where I went wrong.
Yeah. I don't know. Let me see. Determine.
All those numbers, the examples are the actual numbers you had that I plugged in, and then eventually I had to start calculating.
Yeah, that's right. 1 through 3 is correct.
Okay.
That's correct. So 4 is correct. Divide it by 2. That's correct. Go to the Z table and look up your answer in the grid. And so you look up 0.016 in the Z table in the main body. So I'm going to do that right now.
Yeah, make sure that my 0.99 Z statistic is the right answer.
Yeah, it should be 0.99. Is that correct?
Yes, what I got.
Yeah, that's correct.
Okay, well, that's okay then.
Z statistic, basically 1 sigma. Okay. Yeah. So, okay, 0.99. Yeah. So I think 7 is correct. Figure in the sigma shift. So we're going to put the specs 1, sigma's away, but you need to go 1.5 more, which makes it 2. Which should make it around 2.5, 0.99. Okay, that's where you got it wrong.
Okay.
Well, figure 7, you add 1.5 sigmas to the 1 sigma. It's 0.99 sigmas, right? But that'll give me 2.49, not 2.29.
Okay, let me see. Okay, plus 1.5 equals. Okay, 2.49. Okay.
Yeah. Now you take that and divide it by 3. You divided it by 0.99. You need to take that 2.49 divided by 3.
Okay,
Yeah.
the first example is if I wasn't in step 8, the first example is if I wasn't factoring in the shift, and the second example right below it, but that should have
Oh,
been
I see.
2.49.
Yeah.
Okay, so let me do that one. So 2.49 divided by 3. 2.49 divided by 3 is 0.83. 3 duplicate. Okay, and now let me look. I think that might have been your answer. Where's the answer?
Sure.
I think you had the original thing all on one page at the early beginning.
Yeah, I don't know. But you see how to do it, right?
Well, if you're saying that everything I've got there is right now,
Except for that 2.49 you had wrong.
yeah, I got to figure out if I let's see here. 7.
It's towards the end of that module.
I was at the very last page when I started going up. That's why I don't understand how I could have missed it.
Yeah.
What am I here? Seems like you had those original numbers though early on, and then you finished it up later, but I may be wrong. I don't see it anywhere. Okay, so let's go back down to the bottom.
There it is right there.
How did I miss it? Okay, so, all right, so my numbers are definitely different than this though. Let's see here. See, I've got CPK of 2.49 with the shift, 33 without the shift.
Yeah, I don't know. You'd have to go back. I'd have to read through it and look at it. So go back to the very beginning of this problem. Go one slide at a time. Okay, keep going. Keep going. Keep going. Okay, right there. Okay. So we have step 1, step 2, and step 3. And they're all at 3 sigmas, 0.9973.
Yes,
correct?
sir. Yes, sir.
Now scroll down, let's read about it. Now we will assume the steps are independent. So the probability of getting a good part is probability of 1 times probability of 2 times probability of 3, which is 0.9973 to the 3rd power, if you will, which gives me 0.9919. Let me make sure that's right.
Okay, it is.
Okay, which it is. All right, go ahead and go down. Now we will assume you can't skip anything or we'll be in trouble. Okay, so we got lost already. But anyway, let's just read it. When performing capability studies, it's important to focus on the complete process and not just a single steps in the process. With traditional CPK studies, we work with one piece of a large puzzle. This is a weakness in the analysis. Okay, scroll down.
Yeah, that's where it got confusing because some of it was in the video,
It
but
is
not.
more appropriate to determine the standards of the organization in terms of process parts per million, and then determine the CPK must be based on that standard. Anyway, I just given you, I was just trying to teach you need to look at the big picture by multiplying them all together.
Right.
Then I have another video that if you really want to learn how to do this, you can go to, it may be in your account, may not, I can't remember, but you can go to YouTube and type in, how do I determine the proper quality standard for my organization? Then put John Lee in there and a video will pop up and you can listen to that one.
Okay. All right.
And I go through each step in great detail in that video.
Okay. All right. That'll help me then. Okay.
Yeah.
All right. Good. All right. So I don't think there was anything else in this one. Let's see here. This module. No. Okay. So I can close that PDF out. Probability statistics. All right. Permutations and combinations. You're still on my screen. So
Yes.
let's see here. Let's see here. Okay. Yeah. Now this is another one. I could not get the answer.
Okay.
Couldn't figure out what you did or how you did.
When a team consists of 4 black belts and 6 quality engineers. No, don't worry about that one.
Okay.
I throw it on there, but because I saw it on a exam once, and later on you'll get this one, but it's way too complex.
Yeah, I tried every which way but Sunday. I could not get it. Okay.
Don't worry about that one. They're not going to ask you that.
Okay. All right, non-normal distributions. Okay, page 30 of the PDF. How did you get the 4 for the R number of occurrences in the sample number of defectives in N? Okay, so I'm gonna pull that up. How did you
Yeah,
get the get 4 for the R number of
because
occurrences
I
in the
wanted to get
sample?
the 4 best. How many are there 4 best ones? There's 4.
Page 30. I think I'm already on 30. Yeah.
Yeah.
Okay. Let's see here.
So you have two things that can get kind of confusing here. You have number of occurrences in the population and number of occurrences in the sample.
Population is the capital N, and the small n is in the sample. Right.
Yeah. And then D is the number of occurrences in the population.
Right.
And R is what you're looking for. I should have written that, number of defectives in N. But anyway, so D is 4. Would you agree?
D,
What's
number
the
of
probability that the 8 selected contain the 4 best units?
So that would be D.
D is how many are there in the 4 best units? There's 4. It's kind of confusing, I know. But I don't know what your question is either. Are you asking about D or R?
R.
Okay, R is the probability. That's the probability we're trying to calculate. What are we trying to calculate? The probability that the 8 selected contain the 4 best parts. So we're trying to determine the probability of getting 4, correct?
Right.
And that's R. R is the probability that I'm trying to calculate. I'm trying to calculate the probability of getting 4. So R is 4. Whatever you're calculating the probability to get, I'm trying to calculate the probability of getting the 4 best units. Then R is 4.
Okay. See, I thought 4 went into the sample size.
Now sample size is 8.
Okay. The population was 15 parts.
Yeah.
8 selected.
Sample size is 8.
8, and then 4 is the best units.
4 is the number I'm calculating the probability of getting 4 best units. R is that number 4.
Which is 4. Okay.
Yeah,
So if it
and
was
D is 4 also, because how many occurrences does that take place? How many times? Well, it's 4 best units, so there's 4 of them.
So that's where I got confused. Is did I put 4 in D for the number of occurrences?
Yeah.
And I'm like, how did he get R? I thought maybe you subtracted.
They're the same. No, they're the same thing in this question. D and R are the same in this question.
Okay.
Because it's the 4 best units. So
Right.
how many are there? 4 best units. There's 4. Okay, what am I trying to calculate? I'm trying to calculate the 4 best units. R is what I'm trying to calculate. D is what's in the population.
D, well, the population is 15.
No, how many 4 best units are there in the population? Well, there's obviously 4. There can't be anything else.
Number of occurrences in the sample, number of defectives in N.
Okay, how many number of occurrences are in the population of the 4 best units? There's 4.
Yeah,
You're getting confused between R and D. D is what I'm calculating. They tell me calculate the probability of getting the 4 best units. Oh, you want me to calculate the probability of getting the 4 best units? Yes. How many were there? 4 is what I'm calculating for. That's R.
Okay.
D is how many times does that happen in the population? 4 best units. Well, 4. There's 4.
Okay.
In the 4 best units, there's 4 parts.
Right. I guess
that's
just the way
D.
you're asking. Yeah, I guess it's just the way it's asking. It gets confusing.
Yeah. No,
Okay.
it does get confusing.
If you will, give me an example. Maybe it'll help me to understand it better to where D and R would be a different number.
let's say calculate the probability of getting the 3 best units. Then R would be 3, but D would still be 4. Well, I don't know. It's confusing, I admit that. But I can't make it, with the way this question's asked, I can't change it. Because if I
Okay.
change R, D will change. But if it would have said, from a population of 15 parts, 8 are selected at random, what is the probability that, that's where it gets hard, because I said 8 selected contain the 4 best units. What is the probability of getting 2 good parts?
So, and then how would that break down?
I don't know. Oh, I mean, we could do another question, I guess.
So you don't think, I mean, I just hate to get that on a test and not being able to figure it out. Okay.
Yeah. The reason I wrote it this way is because I saw test questions like this, where
Yeah.
R and D were equal, and I
Okay.
saw more of these than the other kind.
Okay. All
And
right,
so
well,
that's why I wrote this one.
okay. Well, the way
But
we
it doesn't
discussed,
mean they can't do it the other way.
right. That's what I was afraid of. Like, okay.
Yeah. But you'll
But
get some in the practice exams, you'll get some that are the other way. And at that point, you may need to call me again, and I'll go through it at that time.
okay. All right. That
Yeah.
sounds fair enough. And
Yeah.
plus, having this conversation will help me to remember.
Yeah.
Okay. PDF. Okay. Same PDF. Next is page 42.
Yeah.
Let's go to there. Poisson distribution. Let's see what it says. In the elements of the formula for the R, you have it as number of defectives. Shouldn't it be defects? Let's see here. Yeah, right here, that should be defects,
Yeah,
right?
that's a typo.
Okay.
Should be defects. That's correct. Good. I'm glad you picked up on that.
Okay, yes. Okay. Okay, now in the you gloss over the Poisson formula and do not give detail on how to calculate it. If this is tested on or elements of the calculations are needed in the future modules or formulas, I need to understand certain elements of it. But it says in the calculations you have 4 for R. Is this because the statement calculate the probability of getting exactly 4 defects in a second?
They're not going to give you that difficult of a problem on the test.
Okay.
They're going to give you problems where you have to use that Poisson table.
Okay.
I don't think I've ever used that formula, but it's not hard to use because you get the average number of defects, correct?
Right.
You see that formula? The probability of getting R equals mean, average percent defective, proportion defective, I should say, to the R power times E, base log E, to the negative mean divided by R factorial.
Okay, now that was where I got stuck as well. Let me see if I've got that written here. Or this is because what is the negative? Okay, the calculations you have for R. Is this because the statement calculate the probability of getting exactly 4 defects in a sector? Do you understand that question? I've forgotten what it meant.
Yeah. Go back to your question.
Okay. In the calculations, you have 4 for R.
Yeah.
Is this because of the statement calculate the probability of getting exactly 4 defects in a sector?
Yes, that's correct.
Okay. All right. Now here's where I got screwed up on the math part. I've never heard of negative mean, and I didn't know how to put that in my calculator to get.
Let me show you. I'll slip it back over.
Yeah, switch back to you.
Okay. So let's say, because it was e to the negative mean, remember? E to the negative mean. Correct?
What was that? It was the E, and then it had a
Yeah, I wrote it this way because I wasn't able to do it on my computer.
the
That
power
they
of.
call this a caret. It means put that in the exponent. So this means that.
Oh, this.
That caret or up arrow means to put this up in the exponent.
The exponent is like the high above the E.
Yeah.
Okay.
So let's say the mean equaled 2, just for sake of argument. Or equals 2, I mean. Okay, now I'm going to put that in my calculator. I'm going to put e to the negative 2. All right? So I'm going to go 2, and I'm going to hit this toggle switch here.
Okay.
See that plus minus?
Yeah, I tried that too. Okay, go ahead.
And it makes it a minus.
Right.
If I hit it again, it'll make it a plus. It goes back and forth. It's called a toggle.
Right. Okay.
Then I'm going to go second function, and right above this natural log button is e to the x.
Okay. Yeah, I see it.
Yeah. So I'm going to go second function, e to the x, and that gives me my answer.
Wow, that's simple, huh?
Yeah.
Okay. Yeah, that's where I got screwed up. Let me see if there was somewhere else I got screwed up on.
Okay.
That was the main thing. I remember that.
But mostly, I don't remember using that formula in the test. Usually I can use the Poisson table, which is much quicker, less likely to make a mistake.
Right. Okay.
So
And
I wanted to show you an example where you actually, where I actually used it in a real situation, but they're not going to test you that way.
okay.
That would take way too much time for a time test.
Okay. And then on the if I'm not mistaken, let me make sure we saw on this. I made a copy of the what you had in the PDF of the Poisson table.
Yeah.
And it was another table that you only went up to like 10. Each table.
That was the binomial tables.
Yeah. Copied that as well. Will that be all I'll need for the exam as well?
Yeah, but those are all in your appendix of your white book.
Oh, okay. Okay. I didn't know. I just been copying everything that you had. Okay.
It's
all
okay.
right. So
it doesn't hurt anything. But realize all those tables are in your appendix of your white book.
Okay. Good.
Now there's also those tables in the appendix of your primer, but they work totally different. So I just stick to the tables in the white book.
Okay. All right. And then I didn't go any further in that problem because I didn't know how to do the negative mean, so that stopped me dead in the track. So I don't know if you want to just do the whole thing now or just have me try to figure it out, and maybe on the next call if I don't.
Yeah, I don't even think you need to do it, to be honest with you.
Okay.
I don't think you're going to have to use that formula.
I kind of thought since you kind of glossed over it, I probably wouldn't need to be tested on it. So that's fine. Yeah, that's fine then. Okay, so let's, I'm pretty sure I'm done with that PDF. Yeah, I'm gonna go ahead and close that out. Okay, next we're gonna go into the Z-statistics inference study.
Yeah.
Constant. And if you'll switch back to seeing me.
Yeah.
Just let me know. Oh, there you go. Share. Okay. On page 20 through 23 and on page 28, you have the formula as this first one where you've got mu minus x bar.
Yeah.
But then on the other pages, you have the numerators transversed. And then on the same thing in the t statistic, all of the formulas are transverse this way versus the first one. So Am
Oh, I
I,
see.
am
It doesn't matter, really.
or let me ask you this. Does it not matter because you always put the high number first anyway?
Yeah, that was my goal. Yeah.
Okay. All right. So that answers that question then. Page 25, okay. Next on page 54, you change the square root of n from the denominator to the numerator. So we need to, okay. Now let me go there real quick. Oh, I thought I had it open. Let's see here. Z statistic, constant, PDF, page 54. What's going on here? Oh, there we go. Page 54. Okay. Now on this one, if you'll remember, you originally showed us this version, but
Yeah.
then you said we're going to switch it to this version. So I
Yeah.
need to pretend I never even saw this one and just use this, right?
Well, just remember when you're dividing by a fraction, see where the denominator is sigma over the square root of n? There's a rule that says you can invert and multiply. And so those two equations will give you the same answer.
Oh, they do.
Yeah, because when you have
Okay,
a
so
fraction in the denominator, you can invert and multiply, gives you the same formula.
see, that's what I mean. I don't understand that. So just to make it simple for me, I can completely eliminate this one and just use this one, right?
Yeah, but they won't make you, I'm deriving it, but they won't have you derive it in the testing center.
Okay.
I was just
All
showing you where it came from.
Okay, but technically, if I want to, for me, simplify it,
Yeah.
I can ignore one or the other.
Yeah, that's right.
Okay, all right.
Yeah.
So that answers that question.
Yeah.
All right, and then now let's see where I got confused again. Okay. Let's see.
Now, what worries me about this, I think it's just recording my screen the whole time. So you're not going to see your questions on that video. But you'll hear you explaining it, so I think you'll be all right.
Okay, yeah, I'll just have to follow along with the document then.
Yeah.
Okay.
Yeah.
All right. So 54. Okay. Then on page 55. Okay. Here's where I got confused. Okay. You were going over that formula,
Mm-hmm.
and then let's see here. Okay. Okay. On page 55, you part number symbol the delta. Okay. You take that formula that I just showed you, and then you say you're going to simplify it, and you're going to start using this symbol here. Do you still see me?
Yeah. Yeah.
Okay,
I'm going to call that mu minus x bar minus mu, whichever way I put it. I'm going to call that delta.
Delta. Now you change it to delta.
Yeah.
So I get that. So I'm good with that. And then you just you stop right there, and you don't solve anything for this. And
Yeah.
but you make a quote. Let me kind of shrink this down so I can read the quote. On the same page, you never solve for anything with that new version there, the delta. And you go straight into solving for n with the new formula for that, which is this one, solving for n. Now, when you said that, the way it sounded like is you were going to solve for n in this delta equation up here,
Yes,
and then
I did.
calculation, but you didn't. It says I thought you were okay. Okay, and then you're going to take the answer that you got from this solving for n and plug it into this delta formula. But instead, you make a statement in the video. Now let's continue solving for n. And all that I do is I move everything over here. and then you
Yeah.
point out the delta solution, and then solve for n. Then you solve for n, and that becomes your answer for the example problem that you have just below that on 57. So I'm confused on how solving for n correlates with the formula on that same page. It don't sound like it does, but
Well,
I didn't know if there was something I missed.
Just solve for the square root of n in that upper formula there. Z equals delta times square root of n divided by sigma. You with me?
Yeah, got that.
So if I solve for the square root of n, I get z times sigma divided by delta equals the square root of n. True?
Okay, say that one more time.
Square root of n will equal z times sigma divided by delta when you do the algebra on that. Square root of n will equal z times sigma divided by delta. Is that true?
Z square root of n. I don't know.
Right.
I understand what you're saying, but I'd have to play that out in my mind a little bit. So what is it that why is it that you're saying that? I'm not understanding that part.
Well, I'm going to switch back to me
Okay.
and solve this for us. So this is what we had, right?
Z delta square root of n divided by sigma, yes.
So I'm going to solve for the square root of n. And to do that, I'm going to divide both sides by delta. Oops. Yeah, I'm going to divide both sides. That'll cancel this out. That puts delta down here. Correct?
I've seen you cancel stuff out, but I don't know what that means. I've never seen it before, so you're confused.
Well, it's just algebra.
Yeah, I never took any algebra.
Oh, okay. That's why this is hard. But anyway, know that when I solve for n in this equation, I'll get this. But because this is a square root of n, I have to square it to get rid of the square root sign. So I square this, that gets rid of that, but I have to square everything else. All you have to worry about is this equation right here.
So the one up above, I don't even need to worry about either?
Nope. This is the one they'll test you on.
Oh.
I was just deriving it, but they're not going to have you derive it on the test. They'll give you a z, they'll give you a sigma, they'll give you a delta, and this they'll call error, or they'll call it they should call it practical significance. But just look at the example problem, make sure you can solve that using this formula, and you'll be fine.
Yeah, I did fine with that formula. And actually it's okay with the other one as well. I just didn't know if there was some kind of correlation there.
No, I was just showing you how to derive it, but ASQ doesn't care if you know how to derive it.
I see. Okay.
Yeah.
All right. Now let's see here. Next question. Okay, yeah, you have to switch back to me so I can show you.
Yeah.
Test. You blow it back up. Here. Okay. All right, if you can see this question, if that's big enough, hopefully.
Yeah, I can see it.
Okay, so in this one, you are willing to take a 5% alpha risk. What is the value of Z critical? And you look that up on the Z table course, and 1.645, of course, is the answer. So that's fine. But the next question uses that 1.645 in the formulation of the answer. and you have a typo in there, so the answer is different than what it should be, it appears to me now. And if you'll see right here in your answer, instead of 1.645, as this says, you've got 1.96.
Yeah, because it's a
Weird.
two-tailed, because it says in the problem plus minus. Go back up a little bit. See what, yeah, stop right there. See where it says defined to be at least plus minus 2 units?
Oh, you mean down here on this question?
Oh yeah, that's where I was looking at it, but it should be up there too.
No, it's not up here. So that's that 1.645.
Oh, it's because you're on a different question.
Yeah, this is a different question. That's what I'm saying is that, so this one here is okay.
Yeah,
Now, and then here, it says, what sample size should you use for the problem below if
Oh,
a
yeah.
practical significance is defined to be at least plus or minus 2 units or 5
okay, stop
alpha
there,
risk?
stop there. So it's 5% alpha risk, which would give you 1.645, but this says plus minus 2 units. Plus minus means two-tailed.
Oh, that's right. That's where I
Yeah.
screwed up.
Yeah,
Oh, no.
that's where you get the 1.96.
Okay, that's right.
On pretty much every test question I've seen on that, on the ASQ exam, and it's highly likely you'll get one of these on the test, by the way. But every time they've used 1.96, just so you know.
Okay. All right. Yeah, that's where I got screwed up. Okay, everything else I understood. Okay. I didn't catch the plus minus. That's where I screwed up.
Yeah.
Okay. All right. Okay, how would you round down? Okay, now just as an example though, since you said you always round down, and I understand like on a like I think you had one of them that was like 15.24, you round down to 15.
Yeah.
On something like where it's kind of right in the middle, do you always round down to a whole number
they'll
like
probably
one?
usually round down because they want to take less. They want to err on the side of alpha risk, not beta risk.
Right. So would you always like in a 1.47, would you
Yeah.
round down that to 1.4 or all the way down to 1?
Well, you can't get 1.4 parts, 1.4 parts.
Oh, that's
You're either going to
part.
get 1 or you're going to get 2. So I'd take 1.
Okay. Okay.
Just on those sample size problems, you do that.
Okay. All right. Now, let's see. Okay, this is the same thing again. The deals were transverse, so that's nothing there.
Yeah.
I can get this. Okay, now I'm in the Z statistic formulas where the standard deviation has changed. So I'm in that next module. Wait a minute. I thought I had a. No, I didn't. I guess I didn't. Okay. That one. This one. Oh, that's the T. Okay, yeah. On these two problems, they're basically the exact same problem. But I could not get the answer that you have here of 1.42 or 210 to save my life. And the question that I had, but I tried both. I tried both routes on this this squared here. I didn't know if I was supposed to square 305 or calculate the whole deal here and then square it. And I tried both ways and I still didn't get the answer. So I'm doing something wrong all the way around. So I was hoping
hold it there, then we'll go to the whiteboard and we'll do it.
Yeah, just go to the whiteboard and show me how you calculate that, and I'll see where I went wrong.
Okay, I'm going to go to the whiteboard.
Okay.
Okay, do you see that?
Yes, sir.
All right, so the first thing I'm going to do is work on these denominators here. I'm going to go 3.05 squared, 3.05 squared.
So you do that squared first, okay?
divided by 19 equals 0.4896. Then I'm going to do the other one. 4.24 squared divided by 19 equals 0.946. Okay, then I'm going to add those two together. Equals 1.4579. Then I'm going to take the square root. It gets me to 1.198. And then I'm going to subtract these. 64.65 minus 64.48 equals 0.17. And I'm going to divide that by 1.198, and it gives me 0.142.
Man, I swear, I mean, it seems like that's how I did, but now that I've got your walking through it like that, I'll check 1.42. Yeah. Man, I swear that's what I thought I did, but I did something wrong, obviously. Now this next that next one I showed you is the exact same deal. So now that I've seen you do it, I don't need you to do that one for me. I'll do that.
Okay.
Just looking at them to make 100% sure. Yeah, they're the exact same. Okay, what you got here? Okay, so now let me go to the next question here. Page 38, you mentioned that once you have looked up the half alpha risk for the two-tailed test on the Z-table, and gotten your Z-sticker, you must then double that number, show for it. Okay. On page 38 of the PDF, you mentioned that once you have looked up the half alpha risk for the two-tailed test on the Z-table and gotten your Z statistic, you must then double that number to show the full risk. Now, you mentioned that in this standard deviation changes, or the, standard deviation changes, you do the same thing in the where it stays the same as well, though, right?
Yeah, the difference is that Z table is a one-tailed test. And if you did a two-tailed test, let me show you.
You gotta double the number. I understand that.
Yeah.
Yeah, I just wanted to make sure that you didn't mention that in the constant, sigma constant. You did mention it in the sigma
Probably
change.
that's probably because the other one was a one-tailed test and this one's a two-tailed test.
Okay, but regardless if it's constant or it has changed, you still do that doubling.
Yeah, it doesn't matter. The only thing that matters on that is it a one-tailed test or is it a two-tailed test?
Right. Okay. I just want to make sure and I assume that, but I just want to make sure.
Yeah.
Okay. All right. Next is in the T statistic inference study.
Yeah.
And let's see here. T statistic inference study. In the video, you mentioned the standard alpha risk is 5%. The critical Z statistic for this is 1.64. T statistic is okay, this means that the two averages must be at least 10 times. However, in the example problems, you state if the calculated value exceeds the critical value, we will remember. Does this mean? Okay, I know what this is. Okay, essentially, when you're looking at the alpha risk of 1.645 for the 5% alpha risk.
Yes.
But in the T statistic, it's 1.729. Okay.
Yeah.
I understand that. Got all that. I understand how that works. But my question is that there's a statement that you make that says that in order to consider something significant, it has to be that 1.645 in a Z statistic study. It has to be the 1.79 in the T statistic to be considered significant. I get that.
Okay.
But when you do an example problem, even when it was a small difference, you had a statement that said that if there is any difference, higher value, if there's any value, we're going to consider that amount significant. So my question is, does that mean that the 1.645 or the 1.72 is already included in the factoring? So in other words, if you even have like a 0.10 increase over 1.645, in other words, your answer was 0.10, it's actually 1.655, right? In other words, that 1.645 is already included. Is that what it means?
No, I have no idea. I have no idea what you're talking about there.
Okay, let me read it and maybe it'll make more sense. Okay.
Yeah.
Okay, so we got the 1.645 and that's established. Okay. Okay. Now, in the example problems that you calculate in the PDF and you come up with an answer, you state, it says, if the calculated value exceeds the critical value, we will consider the population sample averages to be statistically significantly different.
That's correct.
Okay, so that tells me that it is saying two different things. In other words, to me, what you're saying originally is that answer, when you figure out that problem, has to be 1.645 or higher to be considered significant.
Yes, that's correct.
But that's not the way you've been man, I'm trying to figure out how to articulate this. The way that statement that there just amounts is that even if it's less than 1.645, you're still saying that it's considered significant, because you're saying it's just if it's greater than, not greater than 1.645. Does that make sense?
No. Not
okay,
really.
let me try to think. I'm trying to.
So this is the rule. You have two statistics. You have a critical statistic and a calculated statistic.
Right, got that.
If the calculated is equal to or greater than the critical, it's statistically significant.
Okay, now let's stop right there.
Okay.
That's what I'm saying, is that I get that. So in other words, if it's just greater, it can be greater by 0.645 instead of 1.645 is what you just said.
No, it has nothing to do with just the number of your calculated. Let's say your calculated was 1.8 and your critical was 1.645. Okay. So because your calculated of 1.8 is greater than your critical of 1.645, it's statistically significant. Now let's do it the other way. I calculate my statistic and it's 0.2 and my critical is 1.645. So my calculated is less than my critical because 0.2 is less than 1.645. Then it's statistically insignificant.
Right. Now, see, I get that part, but where I'm getting confused is that how much more is it apart? In other words, I thought that the critical and the statistical had to be 1.645 or 1. Well, let's just take one. Let's just take just one of them. Let's just take the Z statistic of 1.645. And now, like you said, if the calculated is higher of any number, it doesn't matter, than the critical, then you're good. But
Well, I don't know what you mean by you're good. It just means that they're statistically significantly different.
right, they're statistically significantly different. Okay, I get that. But I thought that it didn't have to be just greater. It had to be 1.645 or greater to be considered statistically significant.
Yeah, that's true. If it equals 1.645, it's still statistically significant at the
I know,
5%
but if it,
alpha risk.
man, I almost would have to do a problem to get you to understand what I'm trying to say is that if your answer comes out to, okay, instead of 1.65, let's say that when you get your answer, the calculated answer, let's just say is 0.645, not 1.645, okay?
All right.
The answer is 0.645 of the calculated statistic.
Yeah.
That is greater, and let's say, well, let me say it this way: your the calculated is 0.645 higher than your critical. It's not 1.645 higher than your critical, but it is higher. It's not. But it's only 6.645. You see what I'm saying there?
No, I have no idea.
Okay, let me say it this way. All right. I understand that, man, generically, again, shoot, I'm saying the same thing over and over again.
But anyway, you're saying it has to be difference by the when I subtract them, they have to be 1.645 or something. I have no idea.
Yeah, that's what I'm saying is that when you take critical and you take statistical or calculated, I'm sorry, calculated and critical, the way the statement that you made is that it can be any number higher than, excuse me, not yet. The statistical can be any number higher than the critical, but the 1.645 is saying that it can't just be any number. It's got to be 1.645 or higher over critical. That's what I'm understanding it to say. You're saying it can be any number over critical. I thought the 1.645 meant that, or the alpha risk is that if it's over, if your calculated is over your critical by less than 1.645,
no,
then
you
it's
need
not
to forget about
considered
all that. I don't know where you picked up on that, but it's wrong. It's very simple. Is the calculated statistic equal to or greater than 1.645? If you say
Okay.
yes, it is, then
Okay.
it's statistically significant.
Okay. All right. This means that the average. Yeah, I got that from a statement that you made in one of the videos of saying that it had to be 1.645 or greater. That's how I got that understanding, and that's why I was asking the question is that if it can be any number higher, then 1.645 is already factored into the formula. So when it's even 1 point above, like you said, it's yes, because the 1.645 has already been calculated in the formula. So in technically, it's whatever your answer is plus that 1.65.
No, don't do that. I don't know what you mean by the answer plus 1.645. That's makes no sense. You don't add 1.645 to anything. You just compare it. You just compare it.
Yeah, no, you don't add it technically, and physically add it. I'm just saying that because 1.645 is already figured into the formula, that's why any number above the critical works, because 1.645 is already calculated technically in the formula. So does that make sense?
I don't know what you mean by that's calculated into the formula. I don't.
Okay, that's my fault. I'm just not calculating it good. Okay, so let's go on then to the last
Okay.
one. We're done.
Okay.
Let's see here. If you can, you have to see me and see what I've got here.
Yeah, I see it.
Okay, this was in the T statistic.
Yeah.
And this one I quit halfway through the module because I just felt like I was getting so far behind that I just
Yeah.
couldn't figure stuff out. Okay, so this one here is pretty much the same kind of formula that you
Yes, it
showed
is.
me how to do,
Yeah.
is with the X factor of the DF formula
Yes, that's right.
that's used in here. But now I need you to show me how to do this with the DF formula.
Okay.
You could go back to you.
So you need two things here. You need to calculate the statistic, right?
Oh, you got to switch back to you. I'm not seeing what you're doing.
Well, I'm not doing anything. I'm just talking about that formula that's on there.
Oh, okay. Okay.
Where it says 2.57 equals that stuff.
Right. Okay.
So when you do the T statistics, you have to have two formulas. The T, which we calculated to be 2.57, correct?
I thought the formula. I was trying to work the formula to get the answer of 2.57.
Yeah.
No.
Yeah.
Yeah. Okay. So I didn't know how to work it without the DF. So now now that you showed me how to work it without the DF for the Z statistic, I need to know how to work.
The DF is not used in that calculation. The only reason, the only place you use the DF is in the table.
Oh. Oh, so that's where I got confused.
Yeah, DF is just in the table.
Oh, I'll be darned. Okay, I thought for some reason
that's the only reason. That's the only that you calculate degrees of freedom, because you use it in the table to find your critical statistic.
Okay, all right. So,
and this one was degrees of freedom equals N1 plus N2. N1 was 10, N2 was 10, correct?
Yes.
Yeah. So you go 10 plus 10 is 20. Then it says minus 2. So 20 minus 2 is 18. That's where you go in the table and find 18 degrees of freedom. Go over to your alpha risk. It'll give you your critical statistic.
Yeah, I got all of that, and I understood that on the table, but I thought it was supposed to be using this formula too. That's where I got confused. Okay.
No.
Okay, and then other than that, this formula is exactly like the ones you showed me
That's
before.
right. That's right.
So I don't need, you don't need to show me that. So that's it on that then. Okay. Well, that was all of my questions, John. I really, really appreciate you, your patience and your help there. And hopefully I can keep going. I'm strictly in math now, so I may be bugging you a little bit more till I get through this.
That's okay.
Okay, and if you could just shoot me a copy of the recording, that'd be wonderful.
Yeah, I'll do that. I may not be able to email because it'll probably be too big. So I may just publish it on YouTube as a private video, and I'll give you the code to get it.
Okay, yeah, whatever way works for you best. That's fine.
Okay, that sounds good then.
All right, thank you, John. I appreciate it.
Thanks, Kenneth.
Okay, bye-bye.